Hello, this is David Cavuto, Product Manager with Cribl Search. This is part 4 in a 4-part video blog series. In this video, we'll be using the configuration that we completed in the previous 3 videos and actually perform a brief investigation using a public domain dataset. We'll run a search and do some drill down. Then once we isolate a dataset of interest, we'll capture that into our data lake. Then we'll show how using that subset of data is much faster and more efficient for further investigations than using the original full-size dataset. If you haven't completed parts 1 through 3 yet, please feel free to pause here and go back and start with part 1, setting up the data lake destination. If you've already completed the configuration in the first 3 videos, this is the right video for you to watch. For the purposes of this demonstration, we'll use a dataset that's available in the public domain online on GitHub, which is the Boss of the Sock dataset version 3 created by Splunk. We downloaded and decompressed this dataset into an S3 bucket, but made no other changes in format. That data is immediately searchable by Cribl Search. Going into search, we should be able to see that that dataset is configured, and we see that there's a bucket in AWS that has this dataset in it. If we look at our AWS bucket viewer, we should be able to see the Splunk bots v3 dataset right here. And we can see this bucket contains the folders and files that are inside of the bots v3 dataset. We didn't manipulate or change this data in any way. And then as a reminder, we have our data lake dataset that's already been created to search our data lake S3 bucket. If we go back into Cribl Stream, we should see how that data lake bucket was configured. We have a destination called Amazon S3 Data Lake pointing to that data lake bucket. And that is routed to from the source called in Cribl HTTP, which is where the data from search originates. If we look at in Cribl HTTP, that data comes from search and it's being routed back to the data lake. That route is available for us to use now. Let's take a look at the Splunk bots v3 dataset. This is a fairly old dataset. If we execute this search in search across all time, we do get a good sample of it. Now we notice that some of the data is parsed already, but some of it is in JSON format. So if we can pipe it to our JSON extractor, we type extract type equals JSON, and we should see that the events are now extracted. All of the fields inside of those events are fully extracted and parsed into their own fields. Now we'll hit stop and see for a moment, and let's just see how big this data set is. So we'll duplicate the screen, pipe the search to the count operator. Okay, great. So that data set is roughly 2 million events. Let's see if we can understand what the events look like in that data set. So we'll ask to summarize count by source type. Let's assume we've never seen this data set before, so we might want to explore it a little bit. As you can see, this takes some time to actually go through all the data, because that data is being explored in real time, and search is essentially drilling down into every file, reading every event and parsing it to understand what's actually inside of it. We have this field called source type, which comes from Splunk, and we'll pull that out and summarize by it. Notice there's some data that comes from Splunk Stream, that's Splunk's wire data capture product. So we may be interested in looking at some Stream wire data, specifically MySQL Server. We should be able to take a look inside Stream Protocol events and see if there are any MySQL Protocol events. Let's duplicate that tab we had and drill down into this analytic, and let's see if there's anything in the MySQL protocol. So let's first start by seeing if we have any MySQL. We'll ask it to look for stream : star, and then we'll summarize count by source type. Okay, great. And in fact, we do have some stream MySQL data. Great. So now that we know we have that data, why don't we try finding some IP addresses in that data set? If we duplicate that tab, let's maybe see if we can understand anything that might be interesting in the IP addresses. We'll run that extract again, pull out the JSON data, and take a quick look. Great, now we have IP addresses and ports in our event. So maybe what we want to do is summarize by IP addresses and ports. You'll notice, by the way, I keep interrupting search, and that's really because I don't particularly need to see the full result set each time. I'm just looking at a quick little sample. And that's one of the values of Cribl Search. You get fast time to search the result, rather than having to wait for the full dataset to return before seeing anything. What I want to do is summarize here, rather than limit them to summarize by the count by the source IP address. And notice we do get type ahead, destination IP, and we're already looking at MySQL. then we want to sort those results. So we'll say, we'll do an implicit rename, say the count equals count, and then sort by the count descending, like that. Let's pull the pairs that have the most events right to the top. Great. So I think we have a clear winner here, 27,000 events for this IP address pair. So as an investigator, that is something I might be interested in. We know that we have MySQL events on the wire between these two addresses, but we don't know what other types of events we might have. So we might have other types of data from or to each one of these two addresses. So what I'd like to do is pivot on these two addresses and expand rather than just looking at the MySQL events. Let's do the pivot and see if we have other events that contain these two addresses. So we'll click on these addresses, and then we can choose including query for both of those addresses. Now that they've been added to the search syntax, let's actually edit it a little bit so we can delete most of the summarization and just keep the two bare IP addresses, removing the source type filter. Let's see how many events that gives us. And the point here is to pivot to see what events may include any of those IP addresses, and clearly there are a number of them. Remember, however, in the initial search, all the terms are ANDed together. So actually what we might want to do is say events that include IP address 1 or IP address 2, because we probably want to pivot on the possibility of either one of those. So we can use parentheses and Boolean logic to AND this data set together, but or the two IP addresses. And then finally, we don't want to, again, have those full results brought back to the terminal. So why don't we just have the system execute the count? Okay, great. So now we have 254,000 events. Now we compare that to the initial result of 2 million events. So we certainly have only 10% of the events that were in the original dataset that we're potentially interested in looking through. But again, every time we run this search in this form, we have to look through the entire dataset. So we can see that the execution time for searching this sort of subset with these two IP addresses is not really a whole lot faster than the execution time for looking through the entire dataset, which does make sense. And this is where the Cribl data lake will really come to your aid. We can take those events and very easily send them to the data lake. However, we're not going to do that immediately. What we'll do first is tag them. If you remember, we partitioned our data lake using a field called tag. So we're just going to create a tag, and actually let me duplicate that tag here. We'll create a tag by using the extend operator, and we'll call it tag equals bots investigation 1, like that. I'll take a quick look at what that looks like, just so we can get a few events back here. And now every event that we look at should in fact have a field called tag, and it does, bots investigation 1. So now if we want to add JSON, we can get the full field extraction. And then looking at the field events, we can see that the tag actually appears in 100% of the events, as we expected, because we literally just added to the events. So now finally, what we want to do is take that data set and push it into the data lake. So we pipe it to send, and we don't need any other limits. We take all the limits out. We get rid of the time window. This is literally taking every event in the original bots v3 data set that contains either one of those two IP addresses without any consideration for source type or time, and pushing it over into the data lake. And again, we should expect that this search is going to take around the same time the initial search did, which is about 30 seconds, because it's going through the full data set, all 2 million events. So we can see right here that all 2 million events, and only picking out those events that contain either one of the two IP addresses and pushing it back into the data lake. If we were to go over here back to the monitoring tab in stream, we should see that particular route does contain all the events that we are sending, about 230,000 events, which is what we expected. If we go back and look at this last tab, we'll see that the send is now complete. So all the events that were in the specific sub-data set were sent. Now we can start again from scratch with a bare search window. And we can go back into the data lake now, instead of operating from the original bots3 dataset, and we should be able to simply search for tag results. If we search for tag equals, and then we use the exact expression we put in earlier, the tag we created was called bots investigation 1. Now that data should, and we can remove our time window here, because again, we're using the original 2018 time of the data set, we should be able to simply get results, and those are coming from the data lake. Those are exactly the same data set events that we had originally in the bots v3 data set. However, these are specifically and only the ones that have the IP addresses that were one of the two addresses that we filtered for. And you can see right here, 122.60.0.178 is in fact in that event. Let's compare these two approaches. If we were to go back and look at this dataset here, and summarize count by source type in the original dataset, we can see that that does take some amount of time to execute again, because it's going back through the entire bots v3 dataset, scanning it and trying to break it down by source type and looking for anything that contains one of those 2 IP addresses, giving you that result set. We can see that again, it takes almost 30 seconds to execute because it's looking through the whole dataset. However, if we look through that exact same search, except now in the dataset that we extracted into the data lake, hopefully we can see that that search will come back much, much faster. And in fact, it does. That search executes in 5 seconds instead of 31 seconds. Wow, what an improvement. We get the exact same result set, but much faster execution. And that second set has already been pre-filtered by the IP address pair that we're interested in. So now we can operate on that dataset as a forensic analyst or an incident investigator. We can go back into that dataset and we can investigate much, much faster because now we have the dataset of interest that's now been concentrated into the data lake. We can ask it any questions that we were originally looking for. So just to demonstrate the point, we can simply say source type equals, let's say, stream:/MySQL. We should, of course, expect that they're going to be MySQL events here because that's the original thing that we found. But just going back a step, we should also be able to see, for example, HTTP events. And those HTTP events should have at least one of the IP addresses that we're looking for. So if we wanted to take a look here, we could put that filter in here and just sort of see that, in fact, yeah, one of these IP addresses, 172.16.0.178, does in fact appear. So now, again, as an analyst, I have a much more concentrated data set that is germane to my specific investigation. And 2, that data set is now partitioned in a new set of data inside of S3, and it's tagged with the name of the investigation I just created. So when I run my search, it will be as efficient as possible because the S3 is only looking through one specific portion of the S3 folder that has a name tag equals bots investigation 1. And finally, it can look through that data much, much more efficiently because it's only a small fraction of the data. In fact, 10% of the original data set. I hope that summarizes using the data lake in conjunction with Cribl Search and Cribl Stream to make your search experience both more efficient and more focused for the investigations that you're attempting. That concludes the series on creating and using a data loop using Cribl Search and Cribl Stream. Thanks for watching. Again, I'm David Cavuto, Product Manager at Cribl Search, and I hope this video series was helpful to you. Please feel free to reach out to Cribl if you have any questions or comments. Thanks, and happy searching!